Good afternoon, fabulous fourth grade. So today we are going to continue. So today we are going to continue learning about the scientific method and process. I have. Let's go on and share the screen. Boom, boom. Okay. So we're going to use Quizlet just like yesterday. Every time we have our virtual classroom, I'm going to continue to go over the fab vocab just like we would in our normal classroom. And um, to find the Quizlet, let's go to Google Classroom. From Google Classroom, I put it on the stream on the classroom wall. So here's Notre Dame. Here is Chicago. There it is right there. Here is Michigan. Here it is right here. And I'm going to go back to Notre Dame. Okay. So it says, welcome to online learning. This is no different from when I'm out of school and you have to work online. The bonus is that I am here as we learn together. And today we're going to learn about the scientific method and process. So I have a classroom that I created in Quizlet specifically for the fourth and fifth graders. I have some fifth graders, and you guys know that I, even as my fourth graders, I teach you at a fifth grade level so that you'll be more than ready when you do get into fifth grade. All right, so again, we're going to click the Quizlet link and have it opened already, but all right, so we'll click the Quizlet link and it does say fabulous fourth and fifth grade. I just created the classroom. However, I had the set of the vocabulary set yesterday. I created it ahead of time. But anyway, this is the classroom, or at least the group where you can click our vocabulary each week that I upload new vocabulary words. They will be in Quizlet along with the definitions, and you'll be able to find them in your Google Classroom, or I'll directly send you the link on Dojo. So the vocabulary, hey Khalees, Miss Davis sees you. All right, so the vocabulary words, we'll go over them each day at the beginning of class, like I just mentioned. And right now we are working on the scientific method and the scientific process. So the scientific method, again, scientists use this. It's steps. It's a series of steps that scientists use to answer questions and to solve problems. So before scientists answer these, use these steps, they have to first observe that there is a problem. So the way that they observe that there is a problem, they use their five senses. We say sight, we say hearing, smell, tasting, and touching. And so scientists, they make observations using one or more of their senses, and they identify that there is a problem. All right, and so the problem is always in the form of a question. The questions we are trying to answer by doing the investigation or the experiment, right? And so once we identify that there is a problem, once we observe that there is a problem, then we try to figure out a solution to the problem. The solution is our hypothesis. Our hypothesis is usually a if-then statement. It is an educated, testable guess. It's a testable, possible explanation to the problem, usually, again, in the form of an if-then statement. So the example that I gave yesterday was, if the toucan geckos are not surviving in the Amazon rainforest, then it must be because the fire belly pythons are eating them all up. So we had to, we're coming up with a hypothesis, but we have to test our hypothesis by conducting an investigation or even by experimenting, all right? So before we test our hypothesis, before we actually proceed, we have to come up with a procedure. The procedure is all of the steps and the plan that you will take to conduct your experiment or investigation, right? Next, experiment. So I told you guys in class that I don't necessarily like using the word experiment. I like investigation. or investigating, because every investigation is not an experiment, but every experiment is an investigation. So when we experiment, we're testing our hypothesis. Sometimes you may need to do this step more than once to see if the results are the same each time. All right. And then our next vocabulary word is control group. All right. So if I want to, in another investigation, and I told you guys, I love green tomatoes. I love fried green tomatoes. And Miss Davis is a country girl. Y'all already know that. And so if I want to fry some green tomatoes, I need some big, juicy tomatoes. Miss Davis also likes to make chow chow relish that you also make with green tomatoes. So I want the biggest tomatoes where I can take them and slice them up, and I can dice them up, make some relish. But in order to do all this, I need to grow these tomatoes. So I'm going to grow some tomatoes. I'm going to plant the seeds. I'm going to use soil. I'm going to use certain pots, and then I'm going to give each plant the same amount of water and access to sunlight. I'm going to give all of the plants the same amount in the control group. In the control group, I'm not going to change anything. So it's the part of an experiment that does not contain a variable. All conditions are kept normal, and it's used as a standard for comparison. That's my control group. Everything is laid out and it's normal. Nothing changes. So this is how I would normally grow tomatoes. However, in my experimental group, there'll be an independent variable. I don't want to change too many things because my results may not come back. They may not come back true. Or my results, there may be a conflict in them because I changed too many variables. And so in my experimental group, I would only change one variable. And the variable that I change, it would be the factor in the experiment group that I change on purpose. It'll be what I consider the cause, the independent variable. So if I'm trying to grow tomatoes, and I want to see if something will make the tomatoes be larger or grow larger, then I'll use fertilizer. And so the fertilizer, or I'll use maybe more sunlight, or I'll say maybe more water. So whatever I change that's different from the control group is the independent variable, all right? So the dependent variable is the effect. So it's the thing that happens as a result of the independent variable. So if I put fertilizer as my independent variable in the experimental group, then my dependent variable is the size of the plant based off of what I changed in my experimental group. So it's, again, that cause and effect relationship. The independent variable is the cause, and the dependent variable is the effect. All right, so after I'm done with my experimenting, and after I did my investigations, then all of the information that I collect is going to be my data or my data. Some people say data, some people say data. So the data or the data is the information that you organize into charts, tables, drawings, and diagrams. And then you can decide what that information means after you analyze it. And so once I analyze it, then I will draw a conclusion. Now, when I'm drawing my conclusion, that's the answer to my question. It's a summary of what I've learned from my experiment or my investigation. Now, sometimes my conclusions are not going to answer my hypothesis, which means that the if-then statement that I created, I may have to change. And so when you conduct investigations, oftentimes you have to go back in and you have to change your hypothesis. All right, so, and the last thing, if my hypothesis, once I conduct my investigation, I follow through on my procedure, I experiment, gather all my data, and I analyze it, and I place it in my charts, my diagrams, I keep it in my INB, my investigation notebook, then but I find out that my hypothesis is true after I've conducted several experiments, then my hypothesis is now a theory. Oops, let's go back. It's a theory. So a theory is a scientifically acceptable general principle or body of principles, like more than one, offered to explain a phenomenon. So I can say that after conducting my investigations with my green tomatoes, even though they're going to become red, I'm going to catch them while they're green. After conducting this investigation, I can say that me using fertilizer caused the tomatoes to grow larger. And then if I wanted to continue that investigation, I could actually change up the fertilizer. So I'm going to ask you a question later about something else that I could do as an independent variable. So let's move on to the next part of the lesson. All right, so these are the vocabulary words. Once you're finished reviewing the vocabulary words, looking over them, I want you to come down here to where it says match. Now, gravity is a great game to play, but the thing with the gravity is that you have to know how to spell the vocabulary words 100% correctly. So it's really, really challenging, but once you get used to spelling the vocabulary words with accuracy, then I would suggest you doing the gravity game. But the game that I want you to play today is called match. All right, so I'm going to show you how to do the match game. It says make everything disappear. All you're doing is taking the vocabulary word and you're matching it, the term, matching it with the definition. So I'm going to try it first, and I'm just going to show you guys how I work. So I have a time over here, and let's see, an educated testable guess, a testable possible explanation. Ooh, that's the hypothesis. So I'm going to move hypothesis on top of this one. Boom. All right. Part of the experiment that does not contain a variable. All conditions are kept normal. Ooh, that's my control group. Okay. Boom. All right. Let's see. All right. The answer. Oh, okay. The information that you organize is data, data, data. And then, of course, a scientifically acceptable general principle is a theory. Bam. So I got first place. I want to see who can beat Miss Davis' time. All right. And I did it all in under 40 seconds. Okay. That one that got away, that was not my fault. That happened. So anyway, you're going to play the match game. I'm going to go back. Ooh, there's again. Well, okay, I already hit back. So anyway, you guys do that. Try to beat your time. Try to beat my time because Miss Davis got 39.1 seconds. So let's move on. All right, so I want you to study the vocabulary words, and then I also want you to play the match game. All right, so the next part of the lesson, I want you to go back to, actually, you have to come to the video because Ms. Davis does not have a login for all of the scholars. So the next part of the lesson will be a Brain Pop video. And we're gonna watch the video. Remember, I think I'll just play the video twice because the video is only 4 minutes and 16 seconds. So I'll play the video twice. And then after we play the video, you guys will have some questions to answer. Questions. You'll have some questions to answer inside of Google Classroom. So this is where you'll actually go back to the classwork tab. And then when you go to the classwork tab, look for the topic scientific method. So we'll click scientific method, and I have each day will have different material. So like here is yesterday's material, and then here's today's material. And then I'll just keep adding to the topic each week. And then next week when we do a new topic, it'll show up, and then I'll add material to that one as well. So here's the Brain Pop video. Well, actually, these are the Brain Pop questions that you're going to have to answer. The video is not going to be in there. However, the video will be on this feed. So if you want to watch the video again, you'll have to pull up the YouTube video that Ms. Davis is making now, and then you'll just have to fast forward through the video and then go to the YouTube, go to the Brain Pop portion of the video, and then you could just watch that more than one time if you need to help you answer the questions. But then here are the Quizlet vocabulary words. So when you go back into the assignment again, it says Tuesday, March 31st, 2020. You'll click the brain pop, and it'll pop up as a Google form. And then you'll write your name, type your name, you'll type your email, and then you'll answer these questions based off of the video. And then remember to click submit at the bottom. It's only 10 questions. I already typed it out for you, and you just have to select the correct one. That is it. So what we're going to do now is we're going to actually look at the brain pop video. We're going to watch the video twice, and then after we watch the video twice, you'll just go back into Google Classroom. You'll click here, you'll click the brain pop quiz scientific method, and then you'll answer the questions. And then also wanted to show you one more thing back on the screen. Right. Here it is. All right, so I did put the Legends of Learning. The link is here, and I also put it in the other classes as well. The classwork, I moved it to the top. So the awakening, and then animal structure and function. So you could click those and you can still continue to do those. And I also encourage you to keep doing your Compass Learning and your Zearn math. But without further ado, let's get to the video.
Yeah, I know you've been watering it. I'm not sure what's wrong. Dear Timmy Hope, what is the scientific method? From Marcy. The scientific method is the procedure scientists use to help explain why things happen the way they do. When people are trying to understand the world around them, they often come across problems that they just don't know the answer to. This is where the logical, step-by-step method of scientific problem solving comes into play. Like Moby here. He seems to be having a problem with his plant. The first step in scientific problem solving is to recognize the problem. Right. The plant is dying, even though it's getting water every day. Why? To solve this problem, we first need to understand what we already know. Okay, plants need water. What kind of plant is that? Fig tree, right. Now we need to make some observations about the plant. The leaves are brown and falling off, and the soil is wet and swishy. Next, we make an inference. An inference is a conclusion about our observations. From what we observe, we can learn that we use water this time too much. Then we translate our inference into a hypothesis. Well, a hypothesis is a testable explanation for the details you observe. About fig plants do best if you only water them once a week. Sure, it's just a guess, but after our observations, at least it's an educated guess. We'll need to come up with an experiment to test this hypothesis. Here's the plan. We've got 4 healthy fig plants marked A, B, C, and D. They have the same type of pot, the same soil, and they're getting the same amount of sunlight. The only variable or thing that changes will be the amount of water they receive. Plant A will not be watered at all. Plant B will be watered every day. Plant C will be watered 3 times a week. And plant D will be watered just once a week. We'll check back in a month to see what's happened. What do you know? It's been a month, and I'm still wearing the same shirt. Let's record some new observations. Huh, plant A doesn't look too good. Plant B doesn't look so hot either. Plant C looks a little better. Whoa there, plant D is doing all right. Time to analyze our data. Based on this experiment and our observations, it looks like the fig plant did best when it was only watered once a week. From that, we can make a conclusion. Of the 4 watering schedules we tested, fig plants seem to grow best when they're watered once a week. Well, yeah, to be really sure, we should repeat this experiment several times just to rule out accidents and variables we may have forgotten to consider. If the experiments don't support the hypothesis, then the hypothesis has to be rethought, back to the drawing board, so to speak. But if lots and lots of experiments do support the hypothesis, then that hypothesis can eventually become a theory. Well, in science, a theory is an explanatory statement that's been repeatedly confirmed through experimental testing. If a theory is proven valid over and over again, it becomes an accepted piece of scientific knowledge. In the strictest sense, there's really no such thing as scientific fact. Scientists are always learning new things about the world around us, and you never know, they may find some new bit of evidence that forces us to redefine our understanding of the world. Right? Using the scientific method can help you be right more often, and not just in science class. You just have to make sure you do all the steps. If you form a hypothesis without making any observations, you really are just guessing.
Mm-hmm.
And you'll never know if your hypothesis is true or not without testing it with an experiment.
Okay. All right. So I was going to play the video twice, but I think you could just rewind the video, the actual YouTube video of me. And then you could just watch the video again if you need to. So again, once you finish watching the brain pop portion of this instruction, go back to Google Classroom, go down to scientific method, Tuesday, and you click the brain pop quiz. After you click the brain pop quiz, type your name in, type your email in, answer all the questions. They're all multiple choice, and then click submit. Then I'm going to post a question on the classroom wall. Let's see. Create a question. And the question that I have is, in an investigation, ... The one about planting green tomatoes. ... What could be another possible variable? Right. And you could just write your answer there. It's just short answer. All right, just move this down. And just gonna X. And then I'll post it in the other classes as well. All right, scholars, let's come back. Okay, all right, so we have the video and we have our cards. Make sure you go into Legends of Learning. You can click and get some more science practice. And also log into Compass Learning so that you can get that reading and that math practice. And then also Zearn for that extra math practice. Your teachers and I will be here for you from 9 to 3 o'clock. We have questions on the board. You can ask us questions, and you can also message us. I prefer you message me through Dojo because I can help scholars, and I can just go back and forth. All right, so until tomorrow, I love you guys. Have a great day. Bye.